1.5b. We're going to continue our talks on logs and exponents. And so we're going to do some solving equations today. So we did exponents a couple of days ago. All the equations we were solving, we solved in our calculator, which is fine. But now we're going to do them algebraically. Okay? So we've got two parts today, A and B. Yeah.
Are we going to be able to use our calculator on this section test?
Yeah, you need your calculator, but I need to see your work in solving the equations. Work. Expos. All right, let's do some expo equations. Here we go. I've got 4 of them for you. Number 1. Now a reminder when solving equations, write the problem down and work down the page. Some of you guys still work left to right. It drives me crazy. You need to work down your page in column form to solve an equation. You might get a picky teacher in college next year or at Valley next year.
Oh, wait, we're still juniors here, never mind.
Some juniors. Equals 208. Okay, so write this down. 8 plus 5 to the x plus 2 equals 208. That's all raised to the x plus 2, by the way. Do you know what to do first?
Subtract 8.
Perfect. Okay, so we're going to solve this. And solving, you do the opposite of PEMDAS, because we're unwrapping the present. Trying to find out what this gift is. All right, so let's stop right here. When we solved this last week, we graphed y1 and y2. I'm not going to let you do that this time. What you're going to need to do in order to solve an exponential equation is you need to take the log of both sides. Once you isolate the exponent part, the base with the exponent, you need to log both sides. You can use natural log or log base 10 or log base 5 or whatever log you want to do. Or, yep, you can do Lenny every time. I usually just do log base 10 because that's on my calculator. I know where it's at. So don't forget to take the log of both sides. Now, why would we want to take the log of this thing and make it more complicated? Well, we do. Yes. Because this thing that's raised to a power here, we can bring that down to the front. Our log property says that we're allowed to do that. And that's the way we get this down here, and it's not an exponent anymore. So we get x plus 2 times log 5 equals log 200. Perfect, yeah? Divide by log 5. No, yeah, perfect. Be careful here. Divide by log 5. The logs do not cancel out, okay? It's log 200. Close the parenthesis behind it. Divide by log 5. And then we're going to subtract 2. So basically, in your calculator, you would do log 200. Yeah?
Could you just do log base 5 200?
Yes. Yeah. And a lot of people like to do that. They'll take the log base 5, which is great.
Can you explain that?
Sure.
Wait, can you just make the bottom?
Yeah. And then minus 2. And then I think the book has you rounding to 3 decimal places is fine. Sometimes I tell you just to leave your answer in terms of log. And so you would leave it like that. How gross is that? So log 200, close the parenthesis, divide by log 5. You might want to practice this. Get your calculator out. And then subtract 2. So I get 1.292, approximately. It used to be back in the day when you didn't have calculators, you'd have to look up all the logs in a log book. Really bad. Okay, so the way that some people like to solve this, at this point right here, they would rather take the log base 5 of both sides. So when you do log base 5 of 5 to the x plus 2, it's okay, just watch. And then you do log base 5 of 200. When you bring that x plus 2 down, what happens is, what is log base 5 of 5? It's just 1. And then you would do that. With your calculator, most of them, the new ones have any log base. And then subtract 2. So, does your calculator have log of any base? Mine does. Log base 5 of 200. And then minus 2. It's the same answer, just done a little bit different. Did you do it even more differently?
I just didn't do that first step. I just went straight x plus
But it still worked, okay? Okay, then you're fine.
Yeah.
All right, here we go, number 2. All right, so a problem like this, like that you had last week, let's say that you decided to buy a mutual fund, $1,000 mutual fund, and you're going to invest that, and let's say that it averages a 2.3% annual growth. And the question is going to be, how long will it take to reach 2,500? How long to reach? Maybe you have a trip planned and you need to buy tickets to Africa or something. How long to reach $2,500? Okay, we did this problem last week also, but we did it on our calculator, and now we're going to solve it algebraically. So first you need to know that formula from last week. The annual growth, A equals P 1 plus R to the T. And we're going to plug all of our information in and then solve algebraically. So what goes in for A? Good, 2,500. And P would be 1,000. 1.023. Don't forget to move the decimal place over 2 times to the T. Okay, so we're solving, it's another exponential equation. An exponential equation is when we're solving for the exponent. Okay? All right, so first thing I would do is I would divide by 1,000. So divide both sides. So you get 2.5 equals 1.023 to the T. Okay. And so we isolated this power part, so let's take the log of both sides. So log of 2.5 equals the log of 1.023 to the T, but I'm just going to go ahead and move that down in one step. Are you okay with that?
Yes.
Last year you might not have been. This year you're good. Or maybe still not. See that T, when you take the log, you bring it down to the front. Yeah?
When do we have to use a natural log?
Ooh, that's the next one. You can use it here if you wanted to.
When do you ever have to use one?
You don't ever have to. It's just really convenient on the next problem. So then divide, and you get T equals, and go ahead and do this in your calculator. Log of 2.5 divided by log of 1.023. And T is approximately, how many years does it take? 40? It's a long time, huh? Guess you're not going to go on that Africa trip until you're a little older. 40.295, so about 40.295 years. I will probably be dead. You'll still be alive.
Wait, is it almost 25?
Derek would be dead by that.
That's sad to think.
Is it 2.5 or 25?
0.295.
No, I'm saying like log 25 or log
2.5. Yeah. Okay, let me show you one where you would use natural log. Number 3, cruising. Here we go. E to the x minus 4 equals 12.
Oh.
Yeah. Mm-hmm, yeah. Okay, so some of you guys recognize that. You're like, oh, yeah, of course.
Oh, yeah, I probably felt it.
Okay, so first step, add the 4 to the other side. So isolate e to the x. And now you can take the regular log base 10 of both sides if you want to. But it's nice to take the natural log of both sides. So we're going to take natural log of e to the x equals the natural log of 16. You bring that x down, you get x times Lenny. And what's Lenny? He's 1. He's just a little baby. Oh, he's a little baby.
What if her friend watches?
No, she won't. So x equals the natural log of 16. Yeah, all right. And so we get that x is about 2.773. I know I texted her yesterday, told her that I told my kids, and they were crying for her.
Why would you tell your children?
I don't know.
What makes you think, like, good idea?
They'll enjoy it.
They ruined my day. Maybe some way I was trying to ruin theirs. I don't know. Number 4.
Is price equals to x?
x?
Yeah.
I don't know what that is.
Oh.
All right, here we go. 4 to the x. This is the new one. This is the new one. 4 to the x. Guys, can you just be quiet for maybe a little while longer? That would be great. Times 4 to the negative x equals 5. Okay. Now this one's really weird looking, and it's like you look at that like, whoa, that's crazy. All right, you've never done one like this before, so I'm going to walk you through it, okay? So what we're going to do is we're going to simplify this, well, kind of. We're going to go 4 to the x plus 6 over 4 to the x, because that 4 to the negative x, the negative exponent, you can bring it down, equals 5. So we're stuck on that first step? Are we okay? This 4 to the negative x moves down because it has a negative exponent, which makes it positive. Yeah. It's just like if you had 2 to the negative third is really 1 over 8. Okay. All right, so now let's take that whole thing, both sides of this equation, and we're going to multiply it through by 4 to the x, because nobody really wants these fractions here. It's pretty ugly. So let's multiply it through, okay? Now be careful right here. When you multiply 4 to the x times 4 to the x, you don't get 16 to the x or 16x. You get 4 to the 2x. Let's explain that real quick. If you have a to the x times a to the x, you get what? A to the 2x. You add the exponents when the base is the same. Did the base change at all? No. So when I have a 4, it's going to stay 4, and I add the exponents.
What if we don't have the same base?
They will be.
Oh, okay.
They set these up that way. All right, and then distribute here. And here the 4x and the 4x will reduce, leaving you with just 6. And over here we have 5 times 4 to the x. That is not 20 to the x, okay? It's 5 times 4 to the x. All right, now I made it a little bit better, but still super gross. So let's go ahead and get that 5 times 4 to the x. We'll bring it all over to one side. 5 times 4 to the x plus 6 equals 0. Now, there's an interesting thing that you can do here, is that you can make some other variable, let's call it z, equal 4 to the x. Okay? Just bear with me. So z equals 4 to the x. And what I'm going to do is, this is 4 to the 2x, so this is really z squared. Okay? And this is 5z plus 6. Guess what I get to solve? A quadratic. So I'm going to solve this quadratic, and I'm going to solve by factoring. One year I gave one, and it was quadratic formula, and on top of all this, it was terrible. So I changed it to be factorable. What times what? 6 adds up to negative 5, be a negative 3, and a negative 2. Did I lose some of you? I feel like I did. See this 4 to the 2x is the same thing as 4 to the x squared. That's why I could replace that with z squared. Okay, so then z equals 3, z equals 2. Now, those are not your answers. Okay, we're not solving this for z. What are we solving for? X. So go back to where I let z equal 4 to the x, and we're going to go ahead and solve two equations. If z equals 3, I get 4 to the x equals 3, and I'm going to solve that. How do you solve that? Take the log of both sides. Log 4, bring the x down, equals log 3. Sorry, that's going to be over here. And then divide by log 4. So my first answer is log 3 over log 4, which I can get a nice decimal answer. Well, not so nice, but log 3, close parentheses, divide by log 4. X is about 0.792. Okay, and then we'll solve for the other one. So z equals 2. So 4 to the x equals 2 now. Log both sides. You don't? Oh, yeah, you're right. You can just look at it. Very good. Ooh, I like that. I was going to go through the whole thing and log both sides, but yeah, it's just 1/2. 4 to the 1/2 is 2. Perfect. I don't do that often enough. I just do the steps so many times, I don't really just look at the problem. You know, do you ever do that? All right, so you get 2 answers for that problem. Now, are you wondering to yourself, is she going to make me do that on the next test?
Yeah.
Yeah. That might be a bonus question.
Okay, cool. So you gotta learn it.
So if you understood that, maybe this Friday, when I put a bonus question on a quiz, it might be something like that. Okay, we're halfway done. Part B.
Yeah.
Okay. We got lots of time. We're going to do some log equations now. So we just did exponential equations, and now we're going to do some log equations. To do log equations, usually we rewrite them in their exponential form. Okay? You do this all the time. Like we just did one, remember? Log base 2 of x equals 3. How did we solve for x? We were trying to find x, or it was something else, right?
Yeah.
How would we solve for x here? You go 2 is the base. The exponent is 3, so x would be 8. Log equations are hard because you're not doing something to both sides. You know what I mean? Some people, they'll write it like this. Let me show you. If you have that, they'll put a 2 down here and a 2 over there. And then they'll go like that. And it's kind of legal, sort of. But that's how you do it? That's okay. All right, so let's do one. Here we go. Number 5. That wasn't one. Can you leave? Did you just say, can you leave?
No, I said, is that actually legal?
Oh, yeah, you can. All right, log of 2x plus 3 equals log of 15. Okay, now, you've had me for the last teacher for like the last, 2 years? Some of you have? I'm sorry, same old joke, same old things. You know what I'm going to say here. If you have log of stuff equals log of stuff, then what happens? Stuff equals stuff. You're right. Did you? Yes, stuff equals stuff. I love that. I say that a lot because it's true. Log of stuff equals log of stuff. Stuff equals stuff. So you brought me with you to the SAT? Thank you.
Are you going to teach the SAT prep thing?
No,
Did you do a proposal for it?
I've never done it. My dad used to teach it at Wilson. He did an SAT prep in the summer. I took his class but in between my junior and senior year.
Did you ace the SAT math?
No. Actually, he just showed me my scores last when I was over at his house on Sunday.
What'd you get?
In his class, we just take practice one like every week, and the highest I did there was like 660.
Wasn't it out of 2,400?
No, that was it was just the math section. It was out 800.
Oh.
That was the highest I got. I wasn't that good at math in high school. I was really into my boyfriend. Okay, number 6. Here we go.
Who was your boyfriend?
His name was Jeff. All right, log. No, it wasn't Jeff Fortney. Jeff Fortney was my student, people. All right, log of 4x minus 4 equals 2. Okay, here we go. We are going to solve this, and we're going to rewrite it in its exponential form, okay? So what I like to do is I like to change it. Take the base, move it to the exponent equals that. You can even draw little arrows. This is base 10, right? So it's 10 to the second equals the stuff in the log, okay? So 10 squared equals 4x minus 4. Do you remember doing these?
Yeah.
A little bit? 26? Good. So you get 104 equals 4x, so x equals 26. Good job. You can always check your answer, too. Plug it back in. By the way, part A, the exponential equations, there's never going to be extraneous solutions, but these you can have extraneous solutions. Okay? Yeah, let me tell you why. If I have something like this, x, it can be all real numbers. I can put negatives in here, positives in here, no matter what I want. But if I'm solving something like this, if x turns out to be less than 0, it's not allowed. See, there's no restriction on the domain for exponential equations, but there is a restriction on the domain for log equations. So there might be extraneous.
So if it's negative, it's...
Right, yeah, negative or 0. You can't take the log of 0 either. No, do it. Do it on your calculator.
It says error.
Ask Siri. All right, number 7. Log x. What did I say, 7?
Negative.
Oh yeah, you could do. It's imaginary. It is. Yeah, but we don't do logs and complex numbers. That's a bit beyond the scope. Ooh, that sounds wet. Log x plus log 8 equals 3. Are you okay? That's a little congested there.
Ooh,
Yes?
Stuff equals.
No, not this one. I know.
But you combine logs.
Combine them. Yes.
Okay.
Yeah, you got that right.
Log stuff equals logs. Okay.
No, because there's not a log on that side. The only time stuff equals stuff, I know we love to say it, is because it was log of stuff equals log of stuff. That was the only one that we get to say that, by the way. Okay, here we go. We're going to combine this, but you did have that part right. We're going to combine this into one single log. So this is the log of what? 8x. That's why we did that yesterday. Okay. And now we're ready to solve. So we've got 10 to the third equals 8x. Now, a lot of people get stuck at this part. They don't know what to do. 10 to the third equals 8x. 10 cubes, 1,000. Divide by 8. What'd you get? 125? Good. 125. Okay, we're going to do one more. And this one is going to have that extraneous solution I was talking about. 2 log x minus log 3 equals 4. Now it looks like a regular problem, just like the last one where I need to combine the logs together. What happens is if you do solve it correctly, you get an incorrect answer. If you solve it incorrectly, you actually get the right answer, which is kind of funny. I hate that. All right, so we get log of x squared over 3 equals 4. Now don't forget, when you do check your answer, you need to check it in the original problem. The very first problem that's given to you. Not this one that I just went and combined them.
Or you don't check your answer.
Or don't, yeah, and get it wrong. That'd be great. All right, so 10 to the 4th equals x squared over 3. Okay, 10 to the 4th times 3 gives us 30,000. 30,000. And then right here to solve this, we need to take the plus and minus square root of 30,000. If you forget to take the plus and minus square root, you actually get the right answer, which is kind of bad. So what is the square root of 30,000? It's 173.205. So you get 2 answers, but you can just leave it as that. But the negative will not work in the original. Do you see that? If you plug in x equals negative 173.205 into the original x, we're not allowed to take the log of a negative number doing real numbers. And so that one does not work. So a lot of you will forget to take plus and minus square root of both sides, right? Yeah, that happens a lot. That's a very common mistake. And you would have gotten it right.
Yay.
But I would have marked you off a little bit for not getting the wrong answer and checking it shows there's only one right answer. It is. It's very neat. That's why I love math too. You get the problem right, but you can still get it wrong.